Welcome to this live stream for a general discussion on various physics problems. So, if you wish some problems to be answered, please put it in the comment box. I'm available right now to answer to your queries. Mm, okay, I've just got a question. So, is the motion of the planets is periodic or simple harmonic? So first of all, let me tell you the difference between periodic motion and harmonic motion. So periodic motion is basically when a particle repeating its path after a certain period of interval. But if you say that a motion is simple harmonic, in that case there are some restrictions such as the motion definitely must be periodic, and secondly is that the force acting on the particle must be acted towards the origin, let us say the origin, or towards a fixed center. Only then we can say that motion is simple harmonic. So you can say that the motion of the planets are periodic, but the force is not proportional to r. That is one of the criteria, proportional to the distance. And on that basis, the motion of the planets can be treated as periodic motion only, but not the simple harmonic. হ্যাঁ অরুণ, ভালো আছি। হ্যাঁ অরুণ, ভালো আছি। Okay, another question from Tanvi. Why the current in the reverse bias of a generator becomes so high within a very small potential difference? Okay, that's a good question. So, before answering that question, I must tell you one thing. Je, when a Jenner diode is in reverse biased condition, then there is a special type of construction happens in Jenner diode, like its depletion region is small due to high doping of the p and p sides and n sides. So that's why a strong electric field is generated across the potential barrier when the Jenner diode is in reverse biased condition. Fine. So once you just apply the breakdown bias, okay, then the bonds are completely broken, so that a huge number of electrons and hole pairs, electron and holes are generated under the reverse bias condition. So the current rapidly increases, and the each of the bonds have almost the same energy. So around a particular voltage, almost a huge number of bonds are broken. So that's the basic reason behind the sudden spiking or sudden increase in the current in the reverse bias of the general diode. Can we apply Newton's law of gravitation in case of electrons and nucleus? No, definitely not. There is a limitations of this Newton's law. This is basically a long range force. It usually doesn't comes into account when you are talking about the interaction between the electrons and the nucleus. So the force that binds the electron in the nucleus is the electrostatic interaction, and the force binding the nucleons, that is neutrons and protons within the nucleus, that is the nuclear force. So there is a basic distinction between this nuclear force and the gravitational force. You see, gravitational force works over a long distance, interstellar distance, forces between two planets, whereas the nuclear force mostly acts in the nuclear object within the nucleus with a very short range, in the range of few femtometers. Okay. Okay, let me see if there are any questions. Mm, okay, someone is typing. Okay. Is it absolutely necessary for a force to be central to act towards the origin? Yes. Actually, that is a special category of force that we call the central force, and the criteria is that the force must be the function of r. That means the distance between the instantaneous position of the particle and the origin. Number one, and second, the force always has to be directed towards the origin in case of attractive one, and it has to be directed out of the origin in case of repulsive one. That's the criteria of central force. Basically, yeah, the force obeying these properties, those are actually classified as central force. But and not all other force, because there are other force that doesn't obey this law. Like if you say the forces between the nucleons, that doesn't obey this formula. Okay, another question from Srijita. Why the real gases deviates from its ideal nature? Actually, in case of ideal gas, there will be no force of attraction between the molecules. That means there is no intermolecular attraction, number one. And the second is that the gas molecules have very the gas molecules have very small size. That means you can neglect the volume of the gas molecules compared to the volume of the container. Right? That means if you put 1 mole of gas in a container of volume V, you can assume that each molecules access the volume V. Right? So here in case of ideal gas, the volume of a gas means the volume accessible to all the molecules of the gas, average volume, definitely. But if you go for but practically what happens that there is a force of attraction between the gas molecules. That is typically the Van der Waals attraction. Number one, and second is that the gas molecules have finite volume. So when a first molecule enters, it accesses the volume V. But when the second molecule enters, it accesses the volume V minus the volume of the first molecule, and so on. So actually, the volume accessible by the molecules of an ideal gas is much less than the, not much less, but less than the volume of the container. So, how the equation will be modified? We know the ideal gas equation is PV equal to RT. Let us consider for 1 mole of gas. So, first do with the pressure. First term, P is the pressure. So, if as the ideal gases have, there is no force of attraction, but in case of real gas, there is attraction. So, when they collide with the wall of the container, if there is a backward force, then it will collide at lower speed. So, rate of change of momentum will be less. The force experienced by the wall will be less. So, for real gas to behave like ideal, then its pressure should be much more than that measured, and that term is P plus A by V square. And as I have already explained, the volume is V my V. But now, if we consider the volume of the gas molecules, so the accessible volume, average accessible volume per molecule will be V minus something. So the equation should be modified as P plus A by V square into V minus VRT, which is very well celebrated Van der Waals equation of real gas. What is the interconnection between critical temperatures and boil temperature? In fact, there is no such interconnections. Critical temperature is a kind of definition, and boil temperature is a kind of definition. Right? So, critical temperature for a real gas is a temperature below which a gas cannot be liquefied by applying a pressure alone. If we maintain it at the gas at certain temperature, and above that, if you apply whatever with the amount of pressure, the gas cannot be liquefied. Okay, that already shown by Andrews and Amarwas. But the boil temperature is a bit different. That real gas at certain temperature obeys the ideal gas equation. That is what is boil temperature. Yes, we can definitely we can find a relation between them, a mathematical relation between them. TB equal to A by 27 beer and this TC 8 A by 27 B square, like that. We can have a connection, the mathematical relation, but there is no direct physical interconnection between them. we cannot take the Van der Waals equation as universal, because this constants p a and b, that is p plus a by v square into b minus b equal to RT. So this constant a and b again depends on temperature. So that's how the uniformity of or universality of Van der Waals equation is lost. Okay. Yeah. Okay. Pranjal says, is the energy maximum is the only criteria for resonance in force vibration? Uh, to answer, okay, the maximum energy corresponds to resonance. That is what is called energy resonance or velocity resonance. But in case of amplitude resonance, the amplitude must be maximum. So we can categorize the resonance in two different classes. One is amplitude resonance, which mostly occurs just before the velocity resonance. If you say a system is vibrating at some frequencies, and if you apply some external periodic force of frequency omega, and when omega equal to m omega 0, then energy resonance occurs. Then just below that, omega a little bit less than omega 0, the amplitude of the system will be maximum. So that is what is amplitude resonance. What I was saying. So that's why in acoustics you always find two kinds of resonance. One is velocity resonance and another is amplitude resonance. And obviously, in case of energy resonance, the energy is maximum, and also the velocity is maximum. And at that time, mostly the circuit is resistive, controlled by the damping itself. No, no, no. In case of energy resonance, the phase has to be same. The phase of the applied force and phase of the forcing system, that has to be equal, definitely.